Hello, all my Training Tuesday friends. I am Heidi Reese, and I am the Training Programs Manager here at Dayton Superior. I want to thank you all for coming out and taking the time to expand your knowledge with us. We're going to be talking about splicing methods and DBDI. Just a couple of items to go over before we get going with everything. Just want to let you know that everybody's muted. I still want you to ask questions, and you can do that through the chat functionality in Zoom. So just open that up and ask away, and at the very end, we'll have a mini question and answer session for you at the end of the presentation. As a reminder, each and every one of our webinars are recorded, and then they're posted to the website later on YouTube, as well as the DaytonSuperior.com website. All right, so let's get started. This presentation is intended for training purposes only, so anything that we're going to be talking about as far as products that are mentioned in the training, you'll need to go out to DaytonSuperior.com and look for the technical specifications and data around that. Everything can be found out there. Just do a search if you're interested in a product, and you can find that information out. So I'm going to skip the Who is Dayton Superior this week because we've got not one but two presenters, so we want to get through the content. Won't take too long, but just to be safe. So we're going to have a good time with first presenter, Sam Conley. He's our technical service representative in the splicing department, and he joined Dayton Superior back in 2021 as what I just said, the splicing products technical sales representative for the East. And he provides sales support along with technical and product training for his customers, his specifiers, as well as the State Department of Transportation. His 24 years of experience in the construction industry, which is focusing on rebar sales, fabrication, and job site installations, can bring a very relevant knowledge to our trainings. And so that's really exciting to have him here to talk through all of this with us. And he can answer the technical questions that you may have. Sam is also an active member of the Concrete Reinforcing Steel Institute, and that is the CRSI, like we all like to talk about it, in Anchorages and Splicing Committee. So later on in the presentation, we're also going to be hearing from Sarah Clark. She is our Dayton Superior Market Development Analyst, and you may have heard her recent BABA, that's Buy America, Build America Training Tuesday presentation. We did that about a month ago, right, Chuck? Yeah. Okay. And if you didn't, go out and find that gem on the website. And for today, she's only going to be talking through the portion that is relevant to us for the splicing and the products that we're going to be discussing. So a little bit about Sarah. She graduated from the University of Dayton and has a bachelor's in chemical engineering, as well as a minor in environmental engineering. She uses that knowledge every day through her what she does as far as testing, and she works with those groups to get the information in the right hands so that we can validate and make sure that we have the correct DOT testing and standards for you for the products that you need. So with that, I'm going to go ahead and hand it over to Sam, and then he can bridge the gap later on when it's BABA time and talk to Sarah.
Okay, thanks, Heidi. We're going to go ahead and jump right into rebar splicing. We're going to take a look at some of the general splicing methods and definitions, industry standards, why you may not want to use rebar splicing mechanical couplers versus other systems. Take a look at some examples, and we're going to take a close look at the DBDI dowel bar system and that family of products. It's also known as the DBSAE dowel-in. So concrete is a great construction method, but by itself, it's incomplete. It requires rebar to be incorporated into it. Concrete is strong in compression and weak in tension, and therefore the addition of rebar creates the ideal building solution. Rebar is delivered to a job site, cut in various pieces, lengths, sizes. It's bent in various configurations, depending upon which concrete element it's being placed in. So all those pieces are joined together and have to act simultaneously, and contiguous pieces need to act as one, even if there are multiple pieces of rebar. So joining them together can be conducted by and it can be accomplished in several different ways. The bars can be welded. It's not a common situation, and it requires a special type of rebar chemistry, the ASTM A706 rebar. It can be welded. Typically, that can only be done with the approval of the project engineer. Lap splicing is a very common method of joining the bars together. The bars are simply laid together, overlapped, and joined with tie wire. And then mechanical couplers can also be used to complete the assembly. Mechanical couplers potentially have additional materials and parts to accomplish that. The most common methods of mechanical splicing are threaded couplers, shear bolt couplers, grout-filled couplers, and also swedged couplers, which are squeezed onto the end of the bar. It's a little less common. So here's an illustration of a welded splice. The bars are lapped together, and as I mentioned, this requires ASTM A706 rebar in order to be welded together, and typically requires the approval of the project engineer. It's not as common as the other methods of installation. Lap splicing, the bars are overlapped and they are joined together with tie wire. The tie wire has no structural function. It's simply there to keep the bars in place during the concrete placement. The amount of lap length or development length, as it's shown here, depends upon the strength of the concrete, the size of the rebar, and the structural element that the rebar is in. So that length will vary depending upon those factors. Lap splicing presents some challenges. The illustration on the left-hand side illustrates what happens when the concrete goes away. This looks like it was some sort of seismic event that deteriorated the concrete in this column. You can see how on the left-hand side, the bars actually came away from each other because lap splicing is dependent upon the concrete in order to develop its strength, whereas mechanical couplers do not require the concrete to develop its strength. Lap splicing can also present challenges in terms of rebar congestion. And the center photograph there illustrates rebar congestion pretty nicely. As design engineers ask concrete to do more and more with their design in terms of the capacity, the strength, the bearing load, more rebar can be required. And sometimes you just run out of space. It's tough to get the concrete into and around the rebar. So lap splicing can present congestion issues. The illustration on the right-hand side, some of the hooks have been replaced with those circular discs, which are called end anchors. That is one way to effectively and inexpensively address rebar congestion by replacing hooked bars with end anchors. It's becoming more and more common and highly recognized throughout the industry. We're seeing a lot more of it being used. So mechanical splices come in a variety of different iterations. We mentioned before there's threaded rebar couplers, which can be either parallel threads, the typical UNC threads. They can also be tapered threads. This is an illustration of a shear bolt coupler, similar to a Dayton Superior's bar lock product, where the bars are inserted into a steel sleeve and the bolts are sheared off. So mechanical splicing is an alternative to lap splicing and welding. It can be a more economical from a material standpoint, as well as an installation standpoint. It can present savings in both those areas. There's an illustration of standard couplers being used in connecting the bars in that right-hand corner. So mechanical splices offer precise, reliable connections. As I mentioned, they can be a lower cost depending upon the application. And they're stronger and more reliable than lap splicing. As I mentioned, lap splicing is only effective when it's surrounded with a concrete. Mechanical splicing, on the other hand, can act independent, develops its strength independent of the concrete. The strength of the joint comes between the function of the mechanical coupler itself and the rebar. So most of the testing in the industry is done without concrete, and certainly all of the testing that Dayton Superior does in-house, which is very extensive, as well as extensive third-party testing, is also conducted without the concrete. I think the majority of testing that's done with a rebar in place inside concrete happens at the research level, often at universities. Typically, you don't see manufacturers testing in that fashion. Mechanical couplers also provide a superior choice when it comes to cyclic performance, which is especially important during seismic events, and anytime a seismic consideration is taken into consideration, the mechanical splice functions far superior to a lap splice in that case. There are two types of mechanical splices that are defined by the ACI 318 building code, and they're referred to as a type 1 and a type 2 splice. The type 1 splice is less strong than the type 2 splice, and what defines them is that the type 1 splice has to achieve 125% of the yield strength of the reinforcing bar. So I'm going to jump ahead a couple of slides here and take a look at what yield strength really is. We'll come back to that other stuff. So rebar can actually stretch and return to its original configuration. So when stress is applied to that bar and it's pulled, it'll return back to its original configuration up to a certain point. At a certain point, the bar will no longer return to that, and that's referred to as the yield strength. So once the bar has reached its yield point, it's been elongated and will never return back to its original shape. So I'm going to jump back to those definitions again. A type 1 splice is a mechanical connection that achieves 125% of that yield strength of the bar. The stronger of the two types, the type 2, has to meet the type 1 specification, but it also must meet the strength requirement of 100% of the tensile strength of the bar. So the tensile strength is the point at which the bar will break. So there's an example of what happens when we test. In this case, the bar has been pulled apart, it's reached its maximum tensile strength and has broken, and you can see that the mechanical coupler did not break. And so that demonstrates very clearly there that the mechanical coupler is stronger than the bar. So you can see here in this chart of yield and tensile strengths that the typical rebar that we see in the industry right now, most common, is ASTM A615 grade 60. It has a specified minimum yield strength of 60,000 PSI. So in order for it to be a type 1 splice, a mechanical coupler would have to withstand and meet 75,000 PSI, which is 125% of that 60,000. And then the type 2, once again, has to meet 100% of the specified tensile strength of the bar, which you can see here in the chart is 90,000 PSI. So those are the two types of mechanical splices that are in the industry. There are very many type 1 splices out there, but in very specific instances, a type 2 splice is required. Dayton Superior offers both type 1 and type 2 splices. And all of Dayton Superior splices have good performance in both compression and tension. So once the splice has been completed and a compression strength is applied to it, which is a pushing force, and a tension force, which is a pulling apart force, those mechanical splices that we offer at Dayton Superior can perform under both those conditions. You need to take note that there are mechanical splices in the marketplace that can take only one or the other, and sometimes not both. So something to look for when you're looking at specifications and ordering mechanical couplers. So I'm going to jump over that. We already talked about yield strength. Now we're going to take a closer look at the DBDI system. This family of products, the DBDI stands for dial bar, dial in. This is a unique product to Dayton Superior in that the coupler itself is forged from a single piece of rebar. So the bar is inserted into it's heated up. It's inserted into an induction heater. It's heated up to red hot. The end of it is upsized, and then there are several stamping functions that are occur and placed upon that end of the bar where the coupler is formed. That flange that you see is formed, and the hole is punched into it, which is then threaded in a later step. The threaded bar is also upsized in the forging process, and the threads are cut onto the bar after that. So the cross section of the rebar itself is not reduced. Therefore, the DBDI system is a type 2 splice. So that connection is stronger than the bar itself, or it's as strong as the bar itself, 100% minimum of the tensile strength. So those are type 2 for grade 60. Hand tightening is all that's required. There's no special torque wrench that's needed to make the connection in order to develop the full strength. They're available in sizes number 4 through number 11, customizable in various bend configurations. We'll take a look at some other customizable options with that. And they perform as form savers. You can see on the right-hand side, that illustration is where the flange has been mounted to a form. And then in the bottom right, the threaded bars have been inserted. In the center, the coupler and the dowel bar are epoxy coated. They're available in various corrosion protections, including the epoxy coated, Chromex, as well as galvanized. So corrosion protection is a big issue. So we can provide whatever is required for the project. The symbols here on the bottom left-hand side are the IATMO uniform evaluation symbols. IATMO is a third-party independent verification service that Dayton Superior uses. We do extensive in-house testing, third-party testing as well, which is independent. That information is submitted to IATMO. It's reviewed and validated, and then IATMO provides the evaluation to basically say that our products do what we say they're going to. So IATMO is recognized internationally in the design community. So we have those evaluations and certifications available for anybody who might need them for submittals or any engineers that have any questions about them. So form savers can be used in a variety of ways. The biggest issue is that with a form saver, the forming contractor doesn't have to punch holes through his formwork and destroy it. But there are many constructability and safety related issues that also provide benefit for using the form savers. You can eliminate situations that are shown here on the left-hand side in the middle where you've got rebar protruding. If form savers would have been used as shown here on the right-hand side, those bars could have been added at a later date, just immediately prior to the placement of the concrete, eliminating safety hazards. So here's a good illustration of how the form saver works. The mechanical coupler with the flange is attached to the formwork, and this would be at any kind of concrete joint. The concrete is placed. Once the concrete is cured and the form has been stripped. The illustration on the bottom left shows what that would look like, where the flange and the female thread on the coupler is exposed after that stripping the formwork, and so the threaded bar can therefore be inserted into the coupler, threaded in, again hand tight. Those bars then are in place for the concrete placement as shown in the bottom right-hand corner. The male bars as well as the coupler bars can be configured in various different ways. We have available an editable PDF order form that shows all of the configurations on the bottom in order to ease ordering. In order to place the order for a quotation, we need to know the quantity, the part number if we have it, the bar size, and the various bend dimensions. So those order forms are available from your local dealer sales rep or for myself. You can the last time I checked, the order forms available on the website are not editable, but they are there for saving and printout. We can also configure the DBDI system with heads on the ends that can perform as inserts and end anchorages. So they can be configured with the coupler and with the thread itself. The bars can be double threaded for various applications. They can also come with a coupler on each end to in order to provide installation convenience for any configuration. Here's a good illustration of how the flange can actually be clipped. If space is an issue, we can provide the nailing flange with part of it clipped off as shown there. And once again, we forge the end anchors that are used to replace hooks. This is a time-saving and space-saving project or a product for any project that may be constrained by congestion issues. And once again, the engineering world is recognizing end anchors as a viable design option. We're seeing more and more of them being used. Here on the left-hand side, illustrations of that forging process. Bottom corner on the left hand is a photograph of what happens when the product is tested. You can see the bar breaks before the disc pulls out, and various illustrations here of the form savers being attached to forms. And once again, forming contractor doesn't have to put holes in his form work in order to use this product. And once again, various illustrations in the bottom left, you can see the couplers with the flanges attached. The center shows what that looks like after the formwork has been stripped off, and the bars can then be threaded back into that. So that's
awesome. Thank you.
That's quick and overview of DBDI.
Yeah, you did great. So now, Sarah, let's hear from you. Just a real quick, brief overview of the Build America, Buy America. So take it away.
All right. The Infrastructure Investment Job Act was signed by the president in November of last year. And then the final guidance from the Office of Budget Management became in effect on October 23rd, 2023. And they just sent out on October 25th a new memo that kind of goes into more detail on what the guidance is. The Build America, Buy America Act was enacted as part of the Infrastructure Investment Law, also known as the Bipartisan Infrastructure Law. And it's required for all federally funded projects. So all federally funded projects need to meet Build America, Buy America requirements. And it's only domestically sourced products can be incorporated into a federally funded project. So BABA boosts the Executive Order 14005, which was ensuring the future is made in America by all of American workers. So it boosts the Made in America. The BABA Act focuses on maximizing the funded government, federal government use of services, goods, products, materials produced and offered in the United States. The BABA Act requires that all iron and steel products, manufactured products, and construction materials used in federally funded projects for the infrastructure must be produced in the United States. All right, we're going to focus on iron and steel and not construction material and manufactured products, because DBDI is not the manufactured or construction material. So iron and steel, from melt to manufactured, must be produced in the United States. The BABA, the final guidance, defines iron and steel products to mean articles, materials, or supplies that consist wholly or predominantly of iron and steel, or a combination of both. In the context, predominantly iron and steel, or a combination of both, means that the cost of iron and steel must not exceed 50% of the total of the components. So this includes steel products such as bar, wire, plates, casting, forgings. So all of that is included in the cost of iron and steel. All right. So how can Dayton Superior help? So we have a new interactive map on our website that can help you find out what is Build America, Buy America compliant. So you just select a state, the tool populates the compliant products, and it can be filtered to make it a little bit easier into accessories or chemicals. And we'll focus on accessories today because that is the DBDI. So all you'll have to do is click on the product link, and that'll take you to our product page. But if you want a quick view, our TDS and SDSs are there when applicable, mostly TDSs for accessories. The technical data sheets are there to just click, and you'll be able to view them easily. All right, we also have a new landing page for Build America, Buy America. Here you'll find a brief overview of what Build America, Buy America is. It has all the links to the laws, the memos from the Office of Management and Budget, anything that you could think of, and we update it. And my last presentation for Training Tuesdays up there as well. The interactive map, on the interactive map, all the products have DOT approval. Now, it's important that if you don't find a product that you're looking for, it may not need DOT approval. It may meet the specification of a DOT, but not necessarily need a qualified product list approval. So please contact customer service if the product you're looking for is not listed, and we'll be able to help you to see if it could meet your project needs. We also offer certification for Build America, Buy America. Just contact customer service and we'll provide a letter stating that the product is Build America, Buy America compliant. And here's all our quick citations. Again, they're on our website. Heidi will send out that link to our landing page, and you'll be able to find all of these.
I think I'll make Chuck do it today. What do you think there, Sarah? He can send an email out.
Whatever.
Whatever works. Thanks, Sarah. I appreciate that. So guys, we are 1 minute, and I wanted to give you a little time for some questions. So go ahead as I go through the resources slide. Go ahead and put in any questions that you may have through the Zoom chat functionality, and we'll get those answered. So your resources, DaytonSuperior.com is your one-stop shop area for product pages. Sarah talked about that when she went over the tool where you clicked on that link that was provided back to you, and you go to pages that look like this for the specific product that is there. Also, the top piece is the searching functionality. Within that, you can find technical data sheets that correspond to the appropriate products. We have handbooks around that as well. And we've already referenced the DBDI order form. Sam went over that very well. I will look into that, Sam, to make sure we can get the editable one up there. If not, then yeah, you can print it and fill it out. It's there for you. We referred to the IAPMO when we were going through our products, and here is the report. So those are on the website as well. And importantly, if you need to contact someone such as Sarah or as Sam that is referenced here, or your dealer sales manager, technical assistance, you can get that all on DaytonSuperior.com. Just click on the map and find the area for your region, and you can find that information. So I want to give you some great information. We do have a Dayton Superior deal that just started for this month, and you can take advantage of the special pricing on the D101s, which is the dowel end bars, and the D101A straight dowel bar splicer. And just contact your sales representative. I just told you how to do that, and you can get the details, and it's only for November. So do we have any questions? Anybody have any comments or things they want to talk about? We are right at time. Oh, 1 minute over. I'm a fast talker. So giving you just a second to ask a question if you want to. Just a reminder, we put these all out on our YouTube and DaytonSuperior.com website, and you can get all of those and more on splicing, precast, tilt-ups, forming, you name it. Okay, so if there's no questions, I'll go ahead and end today's session. And I appreciate all you guys coming out. And thank you for those who are new to our Training Tuesday today, and I hope you join us next week. Until then.